Happy Saturday, hackers. Welcome to Saturday Hacker Day. My name is Taggart. Thanks for joining us. The Other Bold, thank you so much for the follow. Really appreciate it. Let's turn down these tunes here just a little bit while we get through the first part of the show. As always on this channel, we're doing security, we're doing programming, and we're doing CTFs. Today, we have a really great show. I'm excited for what we're going to be doing. We're finally, after weeks of trying to get this working, we're going to be going over the security onion in all of its glory. But before we do that, as always, we start the show off with the week in cyber news. Three stories that I wanted to focus on this week. The first is a compromise of CodeCov. I don't really know how you're supposed to say that, but since it's short for code coverage, that's what I'm going with. So, long story short here, CodeCov is an online platform that I had not heard about, but apparently a lot of people do use for hosted code testing. Basically, it's a service. Think test-driven development as a service, essentially, right? You host your code there, you run your testing suites on their infrastructure, things like that. Now, CodeCov had a tool called Bash Uploader, which they provided to their customers to upload code to their repository. It turns out that that code had itself, that Bash Uploader had been compromised by a threat actor, and then the malicious code was installed on its client's machines. So this constitutes a supply chain attack, the same nature as the SolarWinds. It's not nearly as severe, but nevertheless, it's interesting to note that we're seeing more of these supply chain attacks happen. I think a couple of really interesting points here. So what was the malicious code able to do? Well, they were able to access internal credentials, including for CodeCov, getting to company secrets. And the other thing that was really interesting was how long the malicious code was resident in the infrastructure. It looks like it's been at least 3 months since initial entry. So that's a pretty long dwell time for something that ostensibly people are looking at and reviewing. And that's one of the lessons that I also took from the SolarWinds compromise, which is that when you have a large code base at scale and you try to automate everything, if you don't do it quite the right way, it can be very easy to miss important things like subtle malicious actors gaining access to your code base and being able to inject their code into whatever you're reviewing. There are a lot of steps in the process that could have prevented both of these compromises. So I think that's something to take away from this. All right, up next, we have a change in Google Project Zero's bug disclosure policy. This is, a policy change might not seem like the most exciting thing, but it's kind of an interesting adjustment to Project Zero's standard operating procedure. If you're not familiar, Project Zero is Google's, or I don't know if it's still, I guess it is still Google. For a while, I think it was being represented as Alphabet rather than Google's. But either way, it's their in-house malware and vulnerability research division. And, big names like Maddie Stone, Tavis Ormandy, they're working at Project Zero and often come up with some really barn burner vulnerabilities in the software that they're reviewing. So what used to be the case is that the research group would wait 90 days after a patch is issued to disclose a vulnerability. They're dropping this down to 30 days after to disclose after the patch is reported. So basically, or after the vulnerability is reported. So basically, Project Zero discovers a vulnerability. They report it right away, or as soon as they have all the evidence that they need. So responsible disclosure, then they're going to say, hey, we're going to write this up in 30 days. We're going to disclose this in 30 days if you, whether you patch it or not. And the idea is that it's trying to encourage vendors to patch more quickly. So it's a little bit more punishing. Maybe that's not the right term. It's a little bit more severe than the policy that they had in the past. And I think what they discovered is that vendors were not patching as rapidly as was, in Project Zero's opinion, safe for the industry. So hopefully this is a motivation to get organizations to patch and update their software a little bit more frequently. So let's see. Disclosure. I'm making sure I have this right. So, okay. So according to threat post, it will delay disclosure of technical details of the vulnerability until 30 days. Oh, I'm sorry. It's actually a lot easier. It's actually nicer. It's 30 days after a patch is issued, if that patch is created within 90 days after disclosure. So it's actually much nicer. I messed that up. So it's actually a lot kinder than what I was saying. What I was saying was like super aggressive. It turns out what they're actually doing is they're giving 90 for patch development, and if you don't have patch development after that 90, then the clock starts ticking, and you got 30 days before they disclose it. So it's like, all told, 120 days if you take no action before patch disclosure. That is different. All right. So sorry I got that wrong. It was a little bit confusing to read, but this is a little bit now I think broader as a policy. I think this is actually more lenient than they had been. And according to this story, the idea is to allow researchers to, quote, decouple time to patch from patch adoption time, reduce the contentious debate around attacker-defender trade-offs, and the sharing of technical details. So basically, Project Zero, and I think this is interesting, they're erring on the side of more secrecy for vulnerabilities rather than less, trying to get vendors more willing to patch. I actually feel good about this, to be honest with you. I'm probably one of the more conservative people in the security conversation when it comes to responsible disclosure. I am not at all convinced that quick disclosure of vulnerabilities with working proofs of concept is a net positive for the industry. It seems to me that more low-level attackers will use proofs of concept than defenders will use to create, advanced detections. You know what I mean? So if you have like indicators of compromise that are easily ingestible by large organizations and patches, of course, that people can install on their systems, those are great disclosures. But full out exploits that work or proofs of concept that are easily taken to that next step into a working exploit, if those are disclosed very, very quickly, what you'll see is a lot of attacks against vulnerable systems. And as a matter of fact, the third story I wanted to talk about today is exactly the evidence for that situation. So we should be all familiar, if we're in this universe, about the recent vulnerabilities in Microsoft Exchange, massive, severe vulnerabilities that were disclosed by Microsoft last month. Now, in a pretty astounding move in the last week, the FBI got themselves a warrant and went and discovered still vulnerable Exchange servers public on the internet that had web shells, so had been compromised by these vulnerabilities. And with the power of this warrant, went ahead and not only copied the web shells off of those systems, but then removed the web shells from those systems. So it's kind of like good guy FBI, but I have some concerns. But before we get to those concerns, let's talk about what's going on here. Hey, thanks for the cheer, Panda Cat. So what's interesting here is that the web shells that we're talking about were present because the vulnerability was disclosed, the exploit for the vulnerability was disclosed so rapidly that folks didn't necessarily have the ability to patch. Now, according to the FBI, they believe that the systems that they're talking about in this case, nobody was ever going to patch them. That the people that run these systems don't have the technical capability to patch them, that they've tried to get in contact with them. We can believe that or not. But regardless, the quick disclosure of basically the full exploit chain of this vulnerability unquestionably made it easier for attackers to go after vulnerable Exchange servers. And I got to tell you, in large organizations, patching things like this, sometimes it can be done quickly, but sometimes it can be kind of a big ask. It can be a heavy lift. And so I do think that this kind of longer tail on vulnerability disclosure is going to make life a little bit easier for defenders. So I'm pretty excited about that. Now, as to what the FBI did, I am not a lawyer. I'm not a constitutional scholar other than as a hobbyist. But I have to tell you that when we think about the Fourth Amendment and unlawful search and seizure, warrants give the ability to search, and they give the ability to seize. But do they give the ability to modify systems? I think it's a gray area. Lasso says, I wonder if I should suggest the same at work for the teams who never seem to patch. Maybe, or just, have a red team and in-house and compromise their systems and demonstrate the risk. That'll make that happen real fast. Yeah, GoPro says, what if I want my Exchange server to be vulnerable, huh? What about then? Well, it's a good point. I think that in this particular case, it sounds like it's a great thing that the FBI did. But it wouldn't be difficult to imagine a situation in which you're running, say, a Tor node or some other software that is legal, but that the FBI doesn't like so much, or some other government entity that goes and gets a warrant, right? And then all of a sudden, this precedent that you're able to modify active systems in the interest of whatever you want to call it, national security or, whatever else. And also, by the way, I think the FBI working in that vein as an investigative rather than a national protection branch, there might be some interesting jurisdictional questions there. But I don't want CISA to be doing it either. I don't want DHS to be doing it either. So, I have some real constitutional concerns about this. And by the way, we're still talking about the internet, right? So attribution can be a little bit funky. And you might think, if the IP is in a United States subnet, okay, but how are you really sure that's where the system resides? There are a lot of questions here, and I think that this will come to be considered as at least a slight overreach by the FBI, even if it was with the best of intentions. I just think I would feel better about it even if they had just copied the malware off for evidence collection. And they do say that they notified the owners or tried to, but the modifying of active systems seems like too much. Now, let's take the other side of the argument just for a moment. Yeah, that's the other thing. Lasso says it'll all be fine until a critical system is accidentally broken by someone doing this. Right, you're trusting the FBI to not mess with your system, right? There's that, but let's take the counterfactual, or not the counterfactual, but the other side of the argument for a moment. Let's say in the physical realm, if you're a law enforcement officer and you're executing a search warrant and you discover something on fire, do you put out the fire? Probably. But is that actually analogous, right? You're modifying the environment in which you're searching because you're stopping an exigent threat, right? Or whatever else. You could imagine other physical threats during an actual search. But is that analogous to modifying running digital systems? I think the argument could be made either way, but I think that argument needs to be made, and I think that we need to have a court decision about it, rather than just law enforcement agencies taking liberties with what a warrant actually means. All right. Descending from the constitutional soapbox, let's talk about Security Onion. Finally, we are going to take a look at Security Onion today. It took way longer than it should have to get all of this going, but we did get it going. And I'll talk a little bit about what some of the struggles were and how I got everything working eventually. But let's get to it, shall we? All right, so let's start by talking about how this thing is working and why it took a million hours to get this thing running the way that I wanted. Hacklist is sorted by GoPro. I think it's because of the slashes that thing is. Oh no, it's the tag. It thinks that you're trying to do cross-site scripting. That's why the chat didn't show up. Hacklist is sorted by 14-day streaming activity. Cool. So this is what I have running right now. You see that it's in Hyper-V rather than VirtualBox. Friends, I tried. I really did to get this thing working the way I wanted in VirtualBox. It just was not happening. Whether it was just the VirtualBox performance on Windows, or whether it was, some like networking problem with the Hyper-V network adapters versus the VirtualBox adapter, it just would not play ball. I also want to call out that the Security Onion ISO does not seem to be the way to go here. Like, you can download the Security Onion ISO and use that to install an instance of Security Onion, but after trying 10 times, I think, with that ISO, it would not create a user account for me. Even if I tried to kind of cheat it and use the live install to root into the installed volume and like use user add to create a user myself, just was not playing ball. When I tried to log in to the machine after I had installed Security Onion from their blessed ISO, I did not have a user account. So I'm not sure what that's about, but starting from an Ubuntu 18.04, it's not stable on 20.04 yet, but starting from an Ubuntu 18.04 base, and then using the, let's look at the installation here, using the git install instructions, I was finally able to get that to work. Now, I was able to get it to work in Hyper-V, and I think that's just about a performance thing. The thing that you need to know about Security Onion is that it's a beast, right? If we look at its minimum specs, like let's look at the specs for eval. 12 gigs of RAM, 4 CPU cores, 200 gigs storage, and a partridge and a pear tree. You really, really need to have a lot of horsepower to throw at this thing in order for it to do what you want it to do. And he's saying these are minimum specs for eval mode with minimal services running. So if you're thinking about Security Onion as an alternative to running Splunk or anything else in your organization, you can do it, especially in a distributed model, right? You can imagine like for a collection node, it's not quite as bad as this, right? For a storage node or something else. But you're still going to have, for your main collectors, they have to be massive bare metal machines, right? And so that's just something to think about. That's where your investment is going to be, rather than, say, in cloud services or virtualization. You'll do some of that, but just be aware that there's going to be some on-prem investment if you do it that way. And in our case, right, I'm running this on my pretty powerful desktop. I built this machine specifically to do virtualization, but even at that, it's taking a large percentage of the resources that I have at my disposal to run this thing. So I think that was part of the reason why VirtualBox just was not going to play ball with this. So I got it running in Hyper-V. Now, a couple of other things to note with the setup. This would be true in any hypervisor, but we'll use Hyper-V as the example here. So I've given this thing 16 gigs of RAM, and I've given it 4 cores. I've also given it 2 network adapters, which is something you have to do. That's not optional for Security Onion. And here's why. Security Onion intends that one of your network adapters will be a sniffer, right? That it's able to run packet capture. And the other one is your management interface. So I have, for for networking reasons, which I can go into, I have the primary network adapter set up as a bridge. So essentially, this thing has an IP on my local network that is in parallel with my desktop's IP address. And the reason for that is because of the way that Security Onion routes its web server, its web pages, right? It if you have a separate IP, even if you have a NAT address, it'll kind of do a redirect to its own local IP address, which means that even if you set it up like in a NAT address, so it has like a 10 dot, like if you're on a 192.168 network and your Security Onion NAT is in like a 10 dot or a 172 dot, even if you have a NAT to port forward to that address, after you initially hit that port forward, it will do a 301 and redirect you to its own IP, which you won't know, or which your host won't be able to contact. So I've just gotten rid of that problem by putting it in parallel on the same network. So it's got the same, it's in the same subnet, everything's fine. The second I have in this isolation lab network. So the idea here is that I'm going to take one of my other VMs, and if I want to run like we'll talk about WinLogBeat and Logstash and some other stuff. If I want to run those things, I can point it to that, or if I want to run malware on one of those things, it is isolated from the rest of the network. It's isolated, of course, from my home system, so I don't have to worry too much about evil getting out of its cage. So that's kind of how we do the setup here. And once it's all set up, what you're met with when you go visit the web interface is and log in is this kind of starting point for your Security Onion installation. And there are a lot of cool things you can do right from here. So to start, we don't have any data in here yet because I wanted to load that up with you live. But if we go into alerts, right, you can see kind of these are system alerts from us, right? I do have some errors here. And this is all coming from the local machine, right? Oh, great. We also have the ability to hunt here. So this is your Kibana, right? Search. Now there's nothing here to see, really. We do have a couple of alerts here from, again, the installation, but nothing really from the network, right? So not a whole lot to do, but this is where we would start using the Onion Query Language, or OQL. Packet capture, we can initialize a packet capture, but of course, there's nothing to capture right now because there's nothing else on this on the capture interface. And the other thing we have is the downloads, which is going to become very important in just a moment. So when you install Security Onion, it creates these installation packages for agents that you can install on endpoints so that you can easily get data going into Security Onion right away. So OS query is pretty heavy. It's imagine like SQL, but for your entire operating system. That's what OS query is. We can also use Waza, sort of the same thing, and WinLogBeat for Elasticsearch. And so what I'm going to try to do first is actually get data from my Windows VM that we're going to test and get data coming into here with WinLogBeat. That's going to be the first part. But also notice that we have all these other tools down here as well. Let's look at administration first, right? It's just users. But if we look at Kibana, right, you can see what this thing starts looking like. And here's where we finally start seeing our elk stack, right? This is supposed to be the secret sauce that we have with Security Onion. This is the easy button for the elk stack. And so here you have it, right? Not a lot to look at right now, but we do have some stuff here. We have some alerts. That we can review. But it's all coming from the installation, right? Because that's all that's happened here. I haven't connected it to anything. We also have Grafana. Did I enable Grafana? I did. So this is kind of a system status dashboard. Really, really powerful. And I could look at this across the hosts that are coming in, right? CyberChef, if we're not familiar. CyberChef is a great tool for, easy decoding. It has a lot of great stuff to, parse encoded data. Really, really handy. Great on CTFs. It's nice that they have that just available for you so you don't have to go out to the GitHub version of it. Playbook and the Hive, I think, are worth talking about a little bit. So let's talk about Playbook for just a second. So Playbook, these are... I don't really know the best way to describe them here. Well, yeah, sure I do. These are essentially Sigma rule definitions. Okay? So this is a way to categorize and work with your Sigma rules right in Security Onion. So rather than, having to, this is how you would define detections for your ELK stack and have them work kind of very, very easily. So you can go get whatever Sigma rules you want and throw them in here. And all of a sudden, now you have your detections without having to convert them. Like if you're running Splunk, right, obviously you can use Sigma C to convert your Sigma rules into a Splunk rule or, whatever sim you're using, QRadar or whatever. But here with Playbook, you don't have to do that. You can just drop these right in here in Sigma format and you're good to go. If anybody's not familiar with Sigma, it's a really, really amazing project. It's a generic signature format for sim systems, right? So it's all done in YAML. You can download this repository and it has basic rules in here to get you started. And the other thing it has is in tools, it has these things like Sigma C. And what Sigma C will do is convert whatever your rule is to whatever your target sim that you need to load the detection in. So again, if you have Sigma rules, which is very commonly the way that detections for threats are released for this reason, if you have a Sigma rule and you're running Splunk or something like that, you can pipe it through Sigma C and get your Splunk rule. You can see in config, these are the different SIM formats that they support, right? There's FireEye Helix, ECS, ArcSight, Carbon Black. So pretty neat project. All right, back to the Onion. And then finally, another way to think about Security Onion is like a sock in a box, right? Which we've obviously seen so far, but one of the things that we haven't talked about is case management. And it's not necessarily a technical concern, but it's absolutely an administrative concern. And so to solve that problem, Security Onion comes with the Hive. All right, great. Thanks for all these errors. So what is the Hive? The Hive is case management. Now you can build pipelines so that the Hive, after a detection, after an alert from your SIM, you can pipeline that directly into creating a new case in the Hive. But even manually, you can do stuff like new case, right? That's case, set up your severity. And then you can also add tasks like nice. We call this traffic light protocol. I have no idea what PAP stands for. All right, so if we create this case, let me turn up the music a little bit. Now we have this this test case here. Or, not. There may still be an issue with my installation somewhere. We'll see how that goes. Interesting. Looks like something's not running, which we can check out. Let's actually SSH into the machine and see if we can figure something out there. Yeah, it is. 5, right? Yeah. So this is an Ubuntu machine, but it's been security ununified, so I have things like SO status built right in. Apparently everything's running, so I don't know what the deal is with that. Yeah, looks like it should be good. I think it may just be waiting for some data. We'll play with this a little bit more, but I think the first thing that I wanted to do is, and this is very commonly the first thing that people want to do with Security Onion, is use the SO import pcap tool, which is kind of one of its hardware requirements. Yeah, SO import pcap, really, really nice tool built right into Security Onion, which will take any packet capture, right, and import it directly into your Security Onion instance, so you'll see it in your Kibana search, and it will match it against any of its Yara rules or anything else that it has for detections to see what it finds. Really, really handy. So we have, I believe, somewhere in here, we have... Yep, we had this Quackbot infection that we were playing with last time. So let's actually throw this at the machine and see how we do with it. So what I'm going to do is I'm going to exit out of here, cd... So I can't do this, interestingly, from WSL2, and that's another thing I wanted to call out from a networking perspective. So Windows Subsystem for Linux 2 has its own network interface, and it is natted in such a way that it is weird and difficult to get out of the WSL2 internal network and into another one of the host OS's virtual networks. It's not impossible, but it's a lot of natting back and forth, and I frankly think that if you can get away without doing it, it's worth not doing it. If I needed to have, you know, some other machine that with a full Linux command line, what I could do is just spin up my other Ubuntu machine, put it on the same network, and connect to it that way. That would be a much easier way to make that happen. So e-learning pcaps. So what I'm going to do here is I'm going to use SCP. To copy this. Oop, got the username wrong. There we go. Okay, so let's SSH into that machine now. So I have the pcat right there. We're gonna do SO import pcat and just give it the 2021, just like that. So it's running against Suricata. which is the engine that's running those detection rules, right? The Yara rules that we just saw. Zeek is slicing up. It used to be called Bro, now it's called Zeek. Is slicing up that packet capture to see if it can analyze it other ways. We're also going to use Zeek manually and another tool in just a moment. And then check this out. It gives us a straight up link directly to the analysis for these events. Although, I don't know if it always works. Yeah, see? If we took off those other filters, it actually worked better. I don't know why. But look at this. Now we have a bunch of alerts that we can follow up on. Bunch of stuff on 443, a bunch of stuff on 80. Now we can filter on this a little bit. We can also change the hunt up here. Now we have the import ID, but we can also do things like destination.port equals 443. And now we're just seeing the stuff that's in 443. Now, I'm not awesome at OQL or, Kibana, if we want to put it that way. And by the way, we're looking here in Hunt. We can also look at this stuff in Kibana, right? If we want to look at it specifically in this interface, we can do that. We have to change up how we're looking at this, though, just a little bit. So if we go back to the Hunt page, you can see that we're looking at February 12th, 2021. So what we want to do is change our time frame here to February 12th, 2021 to, let's say, February 13th, because I think it was just a 1 day worth of logs. And sure enough, now we're getting some stuff. I should change up the timing too. The start date should be 0 hours, right, to get the whole day. And then the end date should be 0 hours on the 13th. Right, so now you see our time range here. And what's cool about this is this is the Zeek breakdown here, with difference of connections, files, SSL, DNS, X509, and alerts. Really, really great breakdown. Look how much more information we're getting already from just looking at this with Network Miner and Wireshark, right? Just from a single PCAP. And we can break this down a little bit more. We go to alerts. Look at these. We're seeing really great alerts here. Possible Quackbot. Sure enough, that's correct. The link here took us, unfortunately, to the last 24 hours, so that's why that didn't work. But now we've got source IPs, right? Really great stuff that we can easily break this packet capture down and really start diving into what's going on here. Let's look at not just alerts, but let's look at our connection data sets. And again, see that timing? Do like last 1 year. See, once I clear that out, I think security, I think Elasticsearch at least, right? The Elk stack is you know, if you configure it correctly, it's about as good as it gets for open source sim, right? And Security Onion is a really killer way of getting all of that running quickly and affordably. So look at these connections that we have, right? We have this breakdown of IP addresses. So clean. Let's actually go back, because another one I love is the DNS. Again, let's knock off the... Here, let's do last 1 year. So we'll see DNS. We won't necessarily see the domain query. But we can use other tools that aren't necessarily as pretty as this to get at that information. Because we were looking at everything here, right? Yeah, let's look at, and those alerts are really nice because we can then see where the alert was coming from. Not last 24 hours, last 1 year, please. Yeah, see how that changes it up? Bad word matching, that's interesting. All right, let's play with this a little bit more. There's another tool that I should have in here. Zeek. Let's see what we have. Find. Oh, that would have been interesting. Oh, it's SO Zeke. Interesting. We don't have... Zeke's just running, but... There should be a Zeek command line. Well, that's actually, you know what? Doesn't matter, because the other tool that we're going to install is going to check our Zeek installation for us and install it if we need it. This tool, so again, this tool is, we're talking about right now just parsing packet captures in really interesting ways. The other tool that I want to use is from, you know, my heroes over at Black Hills Information Security, Rita. It's actually from another company that they run called Active Countermeasures. And Rita is free and open source, real intelligence threat analytics. Basically what it will do is take a packet capture and use really sophisticated statistical modeling to hunt for things like DNS beaconing and other pattern-based malicious behavior that doesn't necessarily show up as cleanly in normal alerting. So it's using that kind of, I think it uses k nearest neighbors is its algorithm for looking for DNS beaconing in particular. They also have a commercial tool called AC Hunter that does this at scale with a really kick-ass dashboard. If you really want to feel like you're in, you know, a Jason Bourne movie or something like that while you're doing your job, use AC Hunter, because this is what the UI literally looks like. So let's install Rita, and Come on. Where's the install button? Let's Rita. Can I just have it, please? Download. Just, I couldn't see things. So we're gonna do the install file here. It does feel like Jarvis, Panicat. You're absolutely right. Fun fact, did you know that for the Iron Man movies, to make all the user interfaces for all of Tony Stark's computers, they used KDE, the Linux desktop environment, because it is so customizable. It was the easiest thing that they had to make the UI look the way that they wanted. That's not why I use KDE on my daily driver laptop, but oh man, I I haven't, but I'm familiar with it. Have I tried the Hollywood command? All right, so let's go get this thing. That's not what we want. Let's go get the install file. Copy link address. There we go. Let's W get that. Okay. And chmod +x install sudo install. All right, so it's getting Zeek set up for us. So this is the part that I didn't want to have to worry about, and I knew that Rita was going to do it for me. Yes, Security Onion has kind of its own Zeek thing going on as part of its IDS, but if I wanted to run Zeek from the command line... By the way, what Zeek does, we should actually take a look at that. It will take some of the stuff that we just saw in here. Not there. Just kidding. Where did we see? Is it just in the alerts? Those breakdowns of our alerting. Here we go. In our data sets right here. Some of what we saw, let's go to last 1 year. Yeah. Some of the data sets that you're looking at here, right? The con, the DNS, X509. Some of what you're looking at is coming straight from Zeek. Because what Zeek does is take packet captures, either live incoming ones or ones that you import through SO import PCAP, and slice them up into these different logs. And they have a really specific format. They're plain text, but they're like a lot. So then what Rita does is from the Zeek logs, it will then further splice those out into anything that it finds that's really, really interesting. Now, this is all very command liney and very plain text, so if you're not comfortable in that arena, you know, it can be a little bit much, but it's all CSVs at the end of the day, so you're able to, you know, load that into a spreadsheet or whatever else you want to do. And, you know, if your org has some money to throw at it, you can just use AC Hunter, which gives you a really nice UI for it. Let's see how we're doing on the install. It is now time to select capture interfaces. Yes, I do want to configure. It's telling me what the interfaces are to sniff on. The correct answer is ETH1 here, which is the second network interface. The others are virtuals, and these are all for the Docker containers. that Security Onion is running. So we'll set it up. We'll set up Zeek to run on ETH1. We'll set it up not to sniff, just because... Oh, yeah. No, I see. It's here are the stats for Docker 0. No, it's not a sniff interface. No. Yes for ETH1. No, 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 no. Oh my god. Oh my god. So many virtual network interfaces. Yep, let's go. Oh man, we have incoming. Hey, X the developer and friends. For those of you just dropping in, we are working with Security Onion and doing some blue team. And we just installed Rita, which is real intelligent threat analytics from active countermeasures. And what Rita does is it allows us to kind of cut through the noise in a packet capture and find the stuff that's interesting. Now, we're already using the Security Onion to work with some of that. Red Team, thank you so much for the follow. Ang31D, thank you so much. So, yes. So Rita relies on Zeek, actually. So the difference is Zeek slices up everything into, you know, con, SSL, file, DNS, X509, right? These data sets that we're seeing here in the Security Onion. That's what Zeek does. Now, what Rita does after that is it uses statistical analysis to look for the really subtle stuff, especially in DNS, right? Things like DNS beaconing. So how do you look for DNS beaconing? Beaconing is about periodic DNS queries, right, to a specific endpoint. That's beaconing, right? Not DNS data exfil, which is a different thing. But DNS beaconing. The thing is that good DNS beacons, not tunneling. So beaconing is just like every once in a while, my malware will phone home to evil.com, right? And to do so, it's using a domain name, so it doesn't look super weird. And good C2 beacons, right, have what's called jitter, meaning that it's not as regular. It's not like exactly every minute or every 5 minutes or whatever. It's not. So what Rita does is it uses statistical analysis and k nearest neighbors. Yeah, exactly, randomized delay. But it uses k nearest neighbors and I think a couple of other tricks to cluster the DNS queries and look for the DNS queries that are most likely to be beacon traffic. And then from there, you can say, okay, some of these beacons are going to be legitimate. Like, for example, if you did a packet capture on your home network and you didn't do any segmentation like you're supposed to, you're going to find that things like your Ring doorbell look a whole lot like C2 because they're beaconing super regularly to their cloud services. So, but you have to know about that, right? So you know that those domains or those IPs are totally legitimate. And then so you parse through the beacons that are really likely that aren't legitimate, and then maybe you find something. So the first thing we're going to do with Rita, we have the... Yeah, no problem. So what we're going to do first is we're going to use Zeek to cut up our PCAP. It does. The other thing that's interesting, so here's the other thing that's interesting about DNS, other than ICMP. I guess you could use ICMP for this. So with the other thing that people will do with DNS is data exfiltration, or straight up use DNS as a C2 channel. And what that looks like, right, is that you set up a domain, you set up evil.com, and then you set up a DNS server for evil.com. And then your C2 will use like base64 encoded chunks as the subdomain, right? So you'll have like 32 bytes of, or whatever, of a subdomain, and it doesn't have a resolution necessarily, but it doesn't have to, because your domain server, right, is going to be capturing that. And then the DNS server on the listener for that DNS server gets that information and recompiles those subdomains into the data that you're exfiltrating from the victim. But again, that's probably going to be happening on a regular basis, so it will look like beaconing as well. All right, so let's see. Got this. I'm going to make a new folder in here because it's going to get messy. This Quackbot sample that we're working with. Can I? Yes, finally, I installed the new version of Windows Terminal. I can finally zoom in with buttons. All right, and then we're going to do... Nope, wrong thing. So, yeah, we're just going to pull this Zeek command. Except that we're going to move it to the 2021. What? Zeek command not found. Is it installed as root? Ugh, it's killing me. That's so annoying. Wait. I think I remember, didn't we see that it was installing Zeek to a specific place? Maybe I don't have it in my path yet, but it's still there. Oh my god, all the network interfaces. Yeah, opt Zeek. Okay, so let's see what's there. There we go. Gotcha. Okay. Let's try that again. Look at all the stuff we just got. So we just got all of these different logs that came out of the packet capture as Zeek has decided to slice it. Now we do Rita import and we give it the folder here. So we do Rita. Okay, Rita's there. Great. Rita import. And we give it Yeah. So give it the path here, and we'll call it Quackbot, because that's what we're playing with. And then from there, we just have this like show beacons, show blacklisted IPs. So Rita gives us all these kind of really nice tools out of the box that will help with our investigation. All right, let's see what we got. Let's see, Rita. Show beacons. Quackbot, I think is how you do it. You give it the data, the data set. Now, look at how this is printing out, right? It's obviously a CSV. And it's a little bit hard to, let me see if I can make this a little bit bigger. Right? It's a lot. So we have score, source, and it's sorted by score, right? With the most likely beacon. The source, the destination, the source IP, destination IP, the number of connections, the number of bytes. And so we could, you know, cut this up a little bit with literally with cut, right? And we could sort it other ways if we wanted. But if we wanted to, we could say no, not Z cut. I mean literally cut. Z cut's already happened. Or Z cut already happened to get it into Rita. Z cut, for those of you who don't know, Z cut is built into Zeek, and it's a way of taking those gigantic Zeek logs that are in this folder, and before getting them into Rita, parsing them down further, right? And Zeek, because the Zeek, let's actually just look at one of these Zeek logs. Also gigantic. So Zeek cut is a tool built in to allow you to parse those logs in a more friendly way. So that's absolutely true. I'm talking about regular old cut, the Unix tool, because what this will allow us to do is just take that CSV that Rita's giving us, right, and get just... Yeah, it does. Zcut will parse different fields from the Zeek logs rather than the Rita logs. Yeah, Zcut, like, here. Do I have Zcut? Let's look at it, right? So if we do cat con.log, and then we'll do like Zcut. Well, actually, let's do head con.log first. Not og. So, look at all these different fields, right? So if we wanted to do at con.log, and then we'll send it to Zeek cut, and then use the D for converting timestamps, right? And we'll include the field TS for timestamp. We already did that. And let's do I want adder port. What's it? Was it ID dot RH? Yeah. And then ID dot response H, right? That's how Zeek cut works. Yeah. Let's actually try, so let's try it with, well, let's, sorry, I wanted to pause on this for just a moment, because, so we've seen how we can break through packet captures in really cool ways. The other thing that I wanted to experiment with on today's stream was actually getting data in real time from a system. And to do that, I need to set up WinLogBeat or Waza, but I want to try WinLogBeat first. So what is WinLogBeat? Think of it as Windows event forwarding without a GPO. So it's a tiny little agent that will take Windows events from a system. It is similar to a fetcher, although it's a pusher because it lives on endpoints. So it's an agent that lives on an endpoint and will send your logs home to Security Onion. So this is how you get a SIM doing SIM things. So when you install Security Onion, it creates these installation packages specifically for you to get that going. Now, when installing packages such as OS/Query or beats onto remote systems, be sure to run so allow on the Security Onion Manager node to allow network access through the firewall. So we'll want to make sure we do that, but first let's set up our networking. Now, I have this machine right here. This is Flare. It's a Windows VM. I've set it up to do malware analysis, but I'm also going to run malware on it eventually. Now, it is currently on the bridge network adapter, but I'm going to change it up to be on the Isolation Lab adapter. Why? Because that is the same network that the Security Onion's second network adapter that we're using for listening is on. Now, there's no DHCP server or anything fun like that going on here, so I'm going to have to set manual IPs on both of them, but that's fine. So, will it be able to talk outside? No, which is the point for this particular exercise. We are isolating this thing so that it cannot talk to the internet. So, yep, you can see that on this is my Flare VM here. Yeah, so this is like, that's a really good point. Well, this is how you do dynamic analysis. So Flare VM, if you're not familiar, this is actually something we're going to be doing in a later stream. But Flare VM comes from FireEye, and basically it's an install script to set up a Windows VM to do malware analysis. So basically, like, once you run it, you get this cool background, but also it installs all of these amazing tools for you to use, right? So if I look in debuggers, I've got OllyDBG, WinDBG, all this stuff that it just installs for me with one command, right? I just run the install PowerShell and it converts my machine into this. Really, really handy for exactly this purpose. Like Kali for Blue Team. Yeah, a little bit, definitely. If you're a malware analysis, I think of Security Onion as Kali for the SOC. Depending on what part of Blue Team you're doing. So, I'm trying to think where I want to go here. Okay, yeah, we need to set IPs. So I'll just set up a 10 dot here. Let's do it in my Security Onion instance first. So IP adder show eth1. I don't have anything there, right? So it's up. So we're going to do IP adder add dev eth1 10.10.1.1/24. Is that right? Okay, well, I gotta do it with sudo, but otherwise, I think I got that right. That's what's up. That right there is me studying for way too long for the Linux Foundation Certified Systems Administrator cert, which is still to this day the hardest practical exam I've ever taken. Way harder than the web app penetration testing exam that I took 3 weeks ago. Okay. So we have a 10 dot here. Now let's go set up this guy. The man pages could be more user friendly. I mean, sure. Oh my god. Alright. 10 dot. You think Windows is ever going to make this more sane? So what am I going to do? The first thing I want to try to do is I'm just trying to create a point-to-point network here to get this Flare VM to send its Windows logs to Security Onion so I can see them coming into the SIM, just like I would in a real environment. That's the first thing I'm going to try to do with WinLogBeat. Then, once I have those logs going, then we're going to infect this thing and see what happens. That's the plan. Alright, I don't think I need a gateway or a DNS server at the moment, because again, this thing is kind of isolated from the world. Okay. Okay, I don't love that. Now, is that because I did something stupid with the Isolation Lab network? No, that should be good. Because private means... Yeah. Nothing. I might have messed up the networking here. Do I have an IP? I do. I don't... No DHCP IP. I set these statically. Right? But the default gateway might be the... Shouldn't need it though, because if I'm sending this stuff internally, the gateway is not going to mess me up. Let's try sudo so allow just to see. That's a really good question. Do I need to define the gateway? No, because it's in the same subnet. So the way that the routing works, right? If an IP address is within the same subnet as your local IP, it doesn't route it to your default gateway. It sends the packet out, right? But it doesn't send it to the gateway. It sends it... well, it sent it directly, right, via ARP. You know what I mean? It finds out who has that MAC address, and then sudo so allow. So we're gonna do log/beat. Yeah. So we're using SOAllow to allow that IP address range to send. Now that doesn't solve the ping problem, but let's get logstash installed anyway. Or sorry, the winlog beat installed. So I'm going to download. Hopefully this works. It should be through RDP clip. So I'm going to take this MSI, copy it over, and then can I send it to here? Sure can. Great. So we'll run this. We'll install winlogbeat and see if we can at least get that going. Get out of here. Interesting. I feel like these aren't loading correctly. Because they're 58K, so... Can I just open these in Notepad? Oh, interesting. I see. So I don't have the permission to view them. That would be why. So where is this? C program data. Let's see what this thing looked like. Elastic, beats, unlog beat, all files. Let's look at fields.yaml. Hello. So this is everything that we're sending. Interesting. Now, I don't think... Get out of here, OneDrive. I don't think that we have successfully gotten this thing going, but just in case. Gotta close out some of these extra windows here, and let's go to Kibana and see if we're getting anything. Don't think so. Not yet. And that may be because... Let's actually look at the configuration here. Because we have this sweet documentation. Well, so I think that I tried to. one of the things that I tried to do is use SO allow to set up the firewall. So it's entirely possible that the network interface doesn't want to play ball with ICMP, but it allowed that other port in, right? And I set that up with SO allow. But we're going to see what else we have going. You're not wrong that I do think that networking is the issue. So we're going to learn about beats. Elastic beats to facilitate the shipping of endpoint logs to Security Onion's Elastic Stack, currently testing his own file beat and winlog beat. In order to, Security Onion must be running logstash. Let's... Oh, is this still happening? Oh, God. What just happened? Oh, okay. It's just a whole bunch of IP tables rules for every single Docker container that's running for Security Onion. Let's get logstash started. Okay, so we have a few other things to do. Oh, you know what? Okay, so let's see. Evaluation mode and import mode do not run logstash, so it needs standalone or full distributed deployment. Oh, whoops. Well, I guess we're not doing this then. But we can use Waza instead. That might be a little bit more interesting. And this does run. And this runs at port 5500 locally and uses the default credentials of user foo and password bar. Keep in mind the API port is not exposed internally. Therefore, firewall rules need to be in place to reach the API from another location. But the API port is not exposed externally by default. Therefore, firewall rules need to be... Oh, yeah, sure. Okay, so we'll use, instead of the winlog beat, we'll use the Waza stuff instead. But I'm getting the sense that I did misunderstand some of the networking. So we have the management interface, right? And we have the PCAP interface. And I think the truth is, and this makes sense, obviously, the PCAP interface just is just the sniffer, right? It's set to it's meant to be on a span tap port. It's meant to be in promiscuous mode. It is not a place to send logs. So we either send it to the management interface or we set up a third interface that we can use for that. And in fact, that's what I'm going to do. So what I'm going to do with Security Onion here is set up a third network interface. In settings, we're going to add hardware. We're going to add a network adapter. And we'll add it to the isolation lab again. Will this work? It should work. Yeah. And let's do IP adder. Actually, IP link. Grep ETH. And there's ETH2. So we just got a new network interface. So what we'll do is we're gonna actually kind of undo the thing we did before. We're gonna IP adder remove. Is it del? It's del, not remove. There we go. And then we're gonna add it to ETH2. Yeah. And then you might be asking, you know, Taggart, why aren't you just using the original network interface that you had? That thing is connected to the internet, and I do not want my Windows VM that I'm trying to test. I don't want that anywhere near my public network, right? I want to keep that thing totally isolated. Even if I eventually have to send it out to the internet, that will be on a separate virtual switch, because I do not want any of that traffic to be seeing anything that's actually on my network. Okay, so that's what that isolation is about. That's why now this machine has 3 network interfaces, physical network interfaces. So now that we have this, let's actually try that ping again. Dang. COVID mask versus suit. Okay, well, this might be part of the issue. Crap. We might have to add a static route here. Oof. IP route add. Dev ETH2. Let's look this up, because I'm not gonna get this right on the first try. Thanks, Nixcraft. There we go. That's it. IP route add 10 dot. Oh my god. Oh, hold up. There it is. Okay. Okay, it's still there. And I still can't get to the thing I'm trying to get to. So, now we're going to do that IP route. Add 10.10.1.0/24 via ETH2. Dev. Sorry. Sudo. Now we have a static route through there. So now let's try that ping again. Dang it. I really thought that was going to do it. Well, let's not give up all hope just yet. Let's see if it's the firewall on this thing. Let's see if we can ping 10.10.1.1 now. Huzzah! Okay, so the network is working. And if we look at the firewall here, yeah, if we like allow, let's go to advanced settings. Let's just allow, very specifically, let's add, yep, that's what we're going to do. We're going to allow ICMP. Not program, port. You know what's funny? I never remember the ICMP port. That's not the window I need to show. Yeah, it doesn't. Okay. It's not a thing. Right. Okay. So this isn't really going to work out this way. Inbound rules. Oh, there we echo request. Okay. There it is. That should do it. That's domain. That's not going to do it. Never mind. This should do it. Okay. Now, thank God. We got there, everybody. Okay, so now we have, and we already have, we have the firewall on the security onion set up to allow the Waza through. Actually, no, we don't. We did it for Logbeat, but not for Waza. Let's do the Waza agent. 10.10.1.0/24. All right, while that's doing its thing, let's go get the Waza MSI. Why did we not do Logbeat? Because we have Security Onion in what's called evaluation mode, which is kind of like everything except for Logbeat. It's the one thing that you don't get with the evaluation mode. So evaluation mode is great for what we're doing right now, but if you were to do like a standalone production instance of Security Onion, it would be even beefier, and it would come with Logbeat. So that's why. The service just isn't enabled. Nope, wrong thing. Let's try that again. What's the agent? I accept. So this is cool. This is like... Oh man, that's really cool. 10.10.1.1, and then we have to do the auth key. Let's look at the documentation for Waza and see if we can... So let's do this, sudo so waza manage over here, once this is done doing its thing. I'm also going to look up that waza auth key. Okay, so coming back to this documentation, we want to try this. We're going to add an agent. Call it Flare. n.10.1.2. Extract key for an agent, please. 002. Okay. Hey, look, it picked it up that the agent name was Flare. Hell yeah. All right, so now we go to our dashboard here in Elasticsearch. I'm just going to overview, actually. I guess we haven't made these dashboards. You should be able to automate this for multiple hosts with shared auth key. I think you can. If I was looking at this, yeah, there is a way to automate this. I'll bet there's a way to pre-game it, right? So like, if you knew the IPs first, actually, just kidding. I bet you can do a register. Yeah, so you can set up a registration service. That's how you do it. So you can set up a registration service that goes and grabs it for you. That's how we do that. Yep. So there was a way to do it with registration, right? We just kind of did it. We actually did it the hard way. Okay. No alerts. Nothing coming in so far. I wonder if... No, because we definitely picked it up, so... Oh, let's get that out. We'll only send alerts or all events. It's a good question. Capabilities. Log data collection. Collect Windows logs. So let's see. Is the Waza agent not running? That was dumb. Definitely running. No, it's not, actually. There we go. Okay. Let's look at how this thing is configured. OSSec agent. Okay. Yeah, it started. And we want to see configuration. OSSec.conf lives where? Okay, C program files. Let's go to C program files. OSSec agent. Sec agent OSSec.conf. Yeah, let's open it with VS Code. And what are we collecting? Wow. That's really annoying. Notepad++. No. What? Man, Flare really messes stuff up. I don't know if it does fetch it from the management interface. Find out. It might, yeah. Sysmon. Oh, interesting. So you can just, like, send Sysmon with WinLogB. Oh, no. Let's see. So Sysmon you can just send straight. That's interesting. It's good to know. Anyway. Oh, do I not have a privileged shell? Is that... Did I seriously do that? Oops. There you go. So it's collecting... Oh, it's basically collecting application security system. I could add PowerShell, presumably, and registry stuff. Wow, that's a lot. And the agent is running, so... Control-Enter, by the way, is query. Still nothing. PowerShell will be process events such as create and so on. Not really. Not without Sysmon. PowerShell logging, let's actually take a look at it. Get when event. Name Microsoft Windows PowerShell operational accidents 10. So it's going to be stuff like creating script block. So like, let's actually max events 1, and then we'll just like read the whole thing. So depending on what it's there, the script block might have some of what was going on in the PowerShell script, but sometimes it doesn't. And that's why sysmon is really, really, really important, because it will give you exactly what you're talking about. You're talking about, you know, event ID 1, process create, event 3, network connection, right? And command line arguments. All of that's going to be in sysmon, parsed a lot more clearly than what you're going to see in the default PowerShell logs. Yeah. Okay. Still nothing going on here. Let's see if we can run the, Okay, nothing to do there. That might not be the right filter either. Let's go back to the security onion hunt. Let's see what we have here. Nope, not there. Not canvas. This is some of this is that I'm not as familiar with Elk as I need to be. I spent so much time in Splunk. Am I working in the blue field or is this just fun? Nope, I'm an analyst by day. I am my day job is as a threat hunter. So I do a lot of this, but just with different tools during the day. And kind of purple team stuff. I'm like on my team, I'm the guy who has offensive skills, so I'm starting to build out a threat emulation program. Nice. Yeah, so similar background for me. I've been in IT not as long as 20 years, but for like 12. And then I was like the IT director of a bunch of different schools, did software development, independent contracting, and then, yeah, moved over to security like 2 years ago. And I love it. All right, so here's everything raw, just in Discover, so you can see kind of what we've got going on. So we'll see, we try like agent.ip, and then a colon, we'll try 10.1.1.2, and there's nothing. Yeah, I agree. Nice to see some blue streams, as most are on the offensive side. Yep, that is true. Most are. Alright, so we're still not getting any data here. So what we're going to do is we're going to try... Oh, I see. Onion agent.id. Agent.name. Yeah, no, that does work. Can we verify that it's pushing data to us? Yeah, let's try. Seriously, this isn't gonna work for me? I was just gonna try to run os sec agent.exe and see if it has some help. Definitely not. Let's look here. Agent management, checking connection with manager. Let's see if we have agent control. We might not. Let's hold on a second. Docker container. I think the problem is this thing is running in a container. Whoa. So, okay, here's what we're gonna do. Sudo docker exec -it so waza and we're gonna run checking connection with manager. This right here. Okay, so it's not it's not that's not working. Although that might not be where it's doing the thing, because obviously that's not the same kind of output we were getting from this. right? So let's see if Security Onion has any more information on this. Nope. Don't want that. Agents. Okay, we did that. We got the key. We restarted the service. We'll restart it one more time. Check the OSSec logs, OSSec log file. It can't phone home. No, I thought we did 1514. I thought we did this. Well, let's actually hold on a sec. This was from 1152. Yeah, no, that's not working. Let's do it again. For this port 1514, right? Yeah. Oh, whoa. No, it is TCP UDP. 10.10.1.2. I'll specifically add the IP address. Ooh. I wonder if Windows Firewall is messing with us. Why can't I click on this? There's some other thing that's open. Oh, yes. Thanks for hiding that. Good job. All right, let's do outbound, and we'll allow outbound 1514 UDP. Or specifically, neat. See program files, OSSec agent. Yeah, I'm creating outbound to allow 1514 GB just in case there's a Windows Firewall rule. Allow everything on Flare as I want the malware to flow. Yeah, let's do that. I don't think this is considered a public, but just in case. Yeah, I don't know. Yeah, it's listing on everything on 15.14, so it should be able to catch it on .1. AV, Defender's already disabled, so we should be good there. Well, it's kind of cool that you're seeing this stuff come in. It's just dropping. Oh. Yeah, this isn't playing ball either. That's disappointing. Well, let's actually, you know what? Let's try something interesting. We actually might be able to do something kind of cool. So now that we have a packet capture interface, theoretically, on here. So let's actually use security unused packet capture to try to pull this. Ooh, sensor ID must match the actual sensor ID. No idea what the sensor ID is. Nah, this isn't gonna do what I want it to do. That's the Security Onion distributed overview. Embarrassingly, I don't remember how to do a ping on a specific port. Do I have nc.exe? No. What? I just turned this off. Yeah, thank you. I was like, wait. nping, right. Did we whitelist the IP in ossec.config? Are you, PandaCat, are you talking about in the server or the client? Do we have... We have a lot of tools on here. I don't know if we'll have nping. We do have ncat, though, so we can just do... Well, that's going to be... No, because it's UDP that we care about. Well, yeah, so the whitelisting should be on the management side. We took care of that with the config, right? We did the SO allow, and we did the agent management. All right, let's do ncat/u, or -u. That's not gonna work. Where is this actually? Windows Start Menu Programs Flare. That's so annoying. Oh, it's in System 32? So it closed the connection. See, that one gets closed remotely. So 1514 is doing its thing. Yeah. So all 1000 scan ports are open/filtered. Yeah. Let's fire up Wireshark. I don't think the issue is connectivity. I really don't. I think the issue is on the server side. What the hell do I have all of these local connections for? All right. Thanks, GoPro. Thanks for hanging out. Yep, there's our 14 Destiny, and then so ICMP destination unreachable. Am I still pinging something? No. Somebody is. Interestingly, us. It's the Onion is trying to ping it, and it can't get there. Even though we've disabled the firewall. Except, yes, we can. Don't know what that's all about. Nothing there. Okay, there's me pinging it. So that's okay. So it is ICMP beaconing, but it's like totally different thing. Did we not authorize it correctly? Was it the wrong key? Okay, this is not where the key configuration is. Let's, yeah, any logs in security I need. So, yeah, there are. We're actually kind of seeing... No, gotta go someplace else. Very different from Splunk. Is it an app armor thing? That would make sense. Let's turn off app armor. Yeah, right. Sudo systemctl stop app armor. Kind of. App armor is a set of policies to limit execution on Linux, particularly on Ubuntu systems. Think of it like SE Linux, but for Debian-based. But because of what Security Onion is doing, there may be issues with it. But I don't know. This looks mainly like telemetry stuff. It doesn't look like it's necessarily... Oh no, there you go. Right here. So that may be related. Doing any better now? No, probably not. What we're going to do is we're going to try to re-add the key. I'm wondering if it's an authentication issue, if we didn't add the key correctly with that little GUI thing. So we're going to try that. If I can't get this to work, I think we're going to call it for today and try it next time. But for now... yeah, let's actually try registration. Okay, here we go. So there's a manageagents.exe here. And here we go. So if we do the import authentication key, is this not a privileged? No. Mm-hmm. Wait. Choose Waza agents host operating system. Yeah. Confirm adding it. Yes. Okay. Like, we definitely already had this. And then we'll, yeah, restart the service. A whole bunch of stuff is about to happen, right? Yep. Still not doing it. That's why. Okay. Invalid IP address. Configuration error. Okay. Let's see if we can fix this thing in real time. Var OSSec. Let's see. Let's vim OSSec .conf. Do I? Yeah, there it is. That should be 1.2, right? I think we found some issues. So the configuration that Waza was showing in the actual Docker container showed an error that one of the things I tried to whitelist was this, and it did not play. So what we're gonna do is we're gonna do let's see if we can restart this and fix it. And then we're going to do so allow again for the Waza agent. And we're going to do 10.10.1.0/24. Because that should have... It already exists. Okay. But now... Okay, this is different. Is Wireshark still running? Cool. I think we can stop this capture. I don't think we're learning anything else from here. Yo! I think we got it. I think we finally got it. Okay. So, problem was at root, don't whitelist quad 0. So two things. One, I might have done the wrong IP, but also for sure, yeah, 0000 does not play ball. So you got to be specific. That's really neat to know. Now, please, for the love of God. Yo, look! We're getting stuff from Flare. That's great. That's all logs. No, I want to see... actual stuff here. See, we got to get out of this dashboard. The dashboard isn't helping us. We need, I think, just discover, right? Yeah, here we go. Here we go. Here we go. So this is where the actual sim is. So based on logs, we wanted to find alerts, yes, and some of the alerts are already going to be present based on the Suricata rules that are already set up. Because this stuff is parsed pretty well already. If you look at it, you can see we have all these fields set up. So for example, we can do process.cmd contains we want to look for PowerShell logs. Yep, thanks a lot. Now it's time to look up the KQL cheat sheet. Yeah. Okay, so let's close some of these because they're not helpful. Here we are, though. Now we're cooking with gas. So we can actually search now the process.cmd for things like PowerShell.exe, and you can kind of see. You can also, can you do group bys? You can do group bys. It's just a little bit different than you do it in Splunk. If I recall, what you would do is, yeah, you filter by type. Here, or you do like, if I do PID, right, I can do add this as a filter. See that? And now I have that as a filter. And if I want to do the command, process.cmd, right? I can add that, and now I can just see the process.command. So this isn't actually a group by, it's just a filter for the columns, so I can see what's going on. Really, really handy. And let's actually see if we can get process. Do I have args? I don't have args for this one. All right. So I think now that we have all this going, then what we'll do next week is we will get this thing connected. Now that, well, it's connected, we will run some malware on the Flare machine and see what we can see in Elastic when that happens. So I think we're going to call it for today. Now, I would normally send you to another stream if I could, but I actually want to call out that today is IntroSecCon. And so there's a conference going on right now, free to attend, for people who are interested in getting started in cybersecurity. So there's a CTF as well. If you want to check this out, I highly recommend it. Go check it out. Talks all day, all weekend. Go do the CTF. I'm going to be doing the CTF myself. See how I do. So that's where I'm going to send you instead of another stream, just because I know that the folks putting this together put a lot of work into it, and the speakers here are excellent, and I highly recommend it. So that's going to be it for today. Thanks everybody for hanging out. Be good to yourselves. Be good to each other. I'll be back on Tuesday with some more Red Team, next Wednesday with programming, and next Saturday we'll continue with this Blue Team stuff and Security Onion, getting some malware to run on our test machine. So that's it, everyone. Have a great weekend.